Assalamu alaikum, and happy to have you here again to all our viewer and participant. This is our second Knowledge Connect from ISA Oman. In this session, we are introducing one of our talented ISA members. Mr. Ahmed Balushi is a motivated development control and automation engineer with experience in both projects, execution and maintenance within the oil and gas industry, currently working with Petroleum Development Oman, PDO. He contributed in the Nimr oil and Sehrul Gas teams, supporting maintenance activities, commissioning multiple projects, and involved in DCS and IPS system. Prior to joining PDO, Ahmed held roles as an electrical and project engineer with KEC International Limited and gained practical training experience with Muscat Electricity Distribution Company MEDC and Mazoon Electrical Company. His diverse background include expertise in residential electrical systems, SCADA engineering, solar system design, and others. Ahmed holds bachelor degree in electrical and power systems and engineering and energy engineering from Sultan Qaboos University. Happy to have you here, Engineer Ahmed.
Thank you, Mr. Nasser, for your kind introduction.
And our topic today about a very demanding topic, which is QMI, one of the specialized area of control and automation, quality measuring instruments. So let's delve directly into that in your topic, and I will leave the floor to you, Engineer Ahmed.
Thank you, Mr. Nasser. So, Assalamu alaikum, everyone. Today we will speak about interesting topic. It is about QMI. It is part of instrumentation activities. We do it in oil and gas industry. So, a QMI, it's a quality measuring instrument in every station. So it playing a very good role, like because they dealing with different type of fluid, and this fluid need to know how much the specific of this fluid. So they're using different techniques to measuring these fluids or production. So I am Ahmed Balushi. I am C&A engineer from PDO. I completed around 2 years now. So I was involved with maintenance activities, with maintenance and the quality measuring instrument team in different area in PDO. So let's go to the introduction. So here we have the introduction. So we have different type of process in oil and gas industries, different type of production. And this production will require proper sampling to know how much this product or the fluid there. And in oil and gas, so they doing proper sampling, and they analyze this component based on the product it have, or based on chemical component it can have. Sometimes we're dealing with different process like water, oil, steam, and gas. And this application will require proper analysis. And we're supposed to using the sampling system to measuring how much we export, or how much we sell for our customer. And the other point is this process analyzer required to measure fluid quality. So before we send any material or any fluid to the third parties, or to the customer, we're supposed to check how much the quality for this. Assume some of of the fluid will contain like corrosive material, which can be affect the line during the export process. And this is very good topic. It's to consider the analyzer, because the analyzer it or doing a good role to measure our process. Yes, to so this actually depend about the safety requirement from the global standard. Also, when we do the analysis by using the analyzer, we can measure how much the composition we have, how much the component percent in that area, because the customer they need to know how much we sell it to them, how much for that, and this all depend about some of the agreement between us and the customer. So and and from the analyzer it's supposed to provide the real-time data, because when we sell the data is supposed to be in the real time, and sometimes the analyzer actually when doing the cycle inside the analyzer, uh, it's supposed to show how much the time it take to to send this data to the DCS or asset management system for record. Because if there is any delay to send this data, uh, we can export like corrosive gases, and this is we need to take in consideration. And so if there is delay in responding, uh, the operator will delay in taking the action. So all the analyzers supposed to be verified, because it need to send the real-time data, and to ensure the data transfer, it is like the specification. It cannot have any corrosive element, any H2S, any environmental impact gases, because it can affect the reputation for the client, or it can be affect the reputation of the company. So these actually we take into consideration. We use different type of method to calculate the environmental impact and to see how much the gases is released. And PDO this day actually uh, have the plan for net zero 2050. Uh, yes. So moving to the next slide, this is how it is introduction about the sampling and analyzer system. So we will have here the production header, and from the production header we will have the probe, and from the probe all the sampling it's needing we need to analyze. It will entering from this pump. After that it will go into the fast loop. Fast loop is supposed to send the data in the real time without any delay. And so this is doing very good role, like such as it is automated system, like before implementing the fast loop, like before 20 years and around that, they're using the manual, which is taking the time. So these days they're using this fast loop because it's automated. After that, the sampling will go into the sampling condition unit, and from the sampling condition unit, it will be connected to the analyzer. So here we will have the quality measuring instrument. They have different type of analyzer based on the application which we required. And after we using or find how much the fluid or uh, the sampling in that element, we supposed to analyze, and all the data supposed to be sent it to the DCS or asset management system for recording purpose. And after that, the retaining sample from the analyzer will go into the sampling recovery system. It is like cylinder or bottle, and it will store the sampling which we analyzed before in the analyzer. So this is like the closed loop, because everything we take it, we need it to return back to the system. Uh, so this is the closed loop, and it's a safety way to measure it. We take in consideration sometimes the temperature during the sampling system. It is supposed to be like constant, depend about the application. Sometimes when we cannot using the analyzer, there is other way. It is through the lab team. So the lab team, they may have different type of analyzer to verify the reading for this analyzer. Some of these analyzer, if we see it is matching, this will be correct. Some of the analyzer in client area, they cannot install that type of analyzer in uh, that application, because it have some regulation or some uh, negative values. So they send the data to the lab, and the lab team, they will analyze these data and will transfer the report, or they put it like they will fill some of the paper and they may put it in the PC to send it. And from that data which they collect, they can see if it is accepted or not. We will move into the other slide. This is showing why we actually needing the analyzer in our system. Because first point, it's critical to the process. We need everything to be verified. It is safety. It not have any corrosive element which can affect our line, our asset. Also, we need to take in consideration the process control. So the it is advanced process control. This is actually if we see it like this day about the AI. So advanced process control, it is like AI because they optimize the values and take the correct action based on that. They save the waste of the production, they optimize the production, and they optimize also the power loss. All of these, they doing the tuning for the PID, and this is very good point to be considered. Also, the analyzer, it is critical to the health and safety, because if uh, anyone, like if there is any release in the H2S and anyone present there, it can be affected. So this means our analyzer is not taking action. And in this case, we need to take in consideration the point where the release of the gases can be appear. Also about the ambient air monitoring, also it is doing the good role here. Also about the moisture and H2S level in natural gas transmission line, because if we speak about the moisture, we will speak about the dew point. So everyone know about the dew point. When it condense, it can be affect the line, and the line there we will have at the pipeline, we will have also the valves, and also we will have other instrument devices. If the moisture we will not measuring correctly, it may affect our asset, and we will lose a lot of uh, money regarding this. Also, it is critical to the environment and reputation. BDO these days actually pay a lot to reduce the flaring system, and we are achieving a very good role regarding this to reducing the flaring, because this is one of our goal related to the net zero 2050. Also, it is about the license to operate. So sometime yes, uh, license to operate. Uh, so every asset they supposed to have different type of flaring or regulation they supposed to be follow. If they achieving that, they will can continue and doing more operation in that case, and the analyzer will doing good role related to this area. Also critical to quality and customer. When any client in any country they need to sell uh, their oil or their gas, they need to check the qualities of their component inside that area. And this is actually doing the good role related to this, because customer pay regarding to the report of or the agreement between them and the client or supplier. Also product quality and custody transfer. So this is related to the previous point. This is about the shipment process of the analyzer. Like there have different type of analyzer in this application as custody transfer, like gas chromatograph, or sometimes for the condensate, they're using different technologies like TVP, RPP, and different technologies the client actually they're using. So we will have different type of analyzer based on their application. First, we will have the physical property analyzer. We will speak about this later on. Also, we will have the specific property analyzer. Also, we will have electrochemical analyzer. So for electrochemical, it depends about the ions. Uh, Ions which they can measure. Basically, it depends about the current or voltage. In this area, we can speak about the pH analyzer. So the pH actually, it's working like if it have amplifier, and from the reading for the pH, it will convert the pH reading, which is scaled from 0 to 14, and it will convert it to the voltage actual reading. After that, they will using analog to digital converter to to convert this voltage to the real reading. And after that, they can see how much the reading for this pH. Properly depend upon the application, but mostly they prefer to using 7 pH. Also, we have the photometric analyzer. We will speak about this later on. Also, chromatograph analyzer. This is good topic because many clients they're using this type of analyzer. Uh, Most common actually gas chromatograph, and other also they're using like different clients they're using like liquid chromatograph. It depends about the application, but this is good point to be highlight. Also about the chemical analyzers. So we will moving to next slide. So here we will have the physical property. If we this is just example about type of physical property. Every reading we take it from this analyzer, it is supposed to be engineering unit, such as ppm value, percentage, mole percentage, different values uh, they taking in consideration. So if we speak first about the density, we will have different type of density. So we will have density meter and density analyzer. So there is some difference between these two applications. Also, sometimes we're using physical property and specific gravity. Also, the viscosity. Also, sometimes for boiling point and flash point. Also, the freeze point. So they often require a particular sample temperature. So most application in oil and gas, they're using a heating source to have proper analysis for their sampling. Yes, if we speak about, for example, if we speak about previous gas chromatograph, they supposed to have heating, and this heating supposed to be in the column to doing more separation, more separate for the component in different practical. And from the heating, we can see how much this element can react. Also, the heat exchange system may be required to control the temperature of the incoming sample. So this is one of the key elements here related to the physical property. And we also have the specific property. Here we're measuring a unique property of the sample. For example, we can using to know the paramagnetic oxygen or sometimes dissolving oxygen analyzer. And this is actually very good point to be highlight, because here it depend about also the heat. We heat the sampling, and from there, if we heat it, it will moving to the magnetic field density, magnetic field area. And from the magnetic field, the molecules will be moving between thermistor, because we heat it. And from this heating, we can see how much the pressure drop or differential pressure between the places in the places in that analyzer. This is one of the key points we need to highlight. And from that pressure difference uh, reading, we can convert this reading to the temperature. From the temperature, we can reflect this reading. If the temperature is increasing, what will be the resistance? And from the resistance, we will convert the values to Weston bridge. And from there, we can calculate the exact voltage or the resistance, variable resistance. Also, we're using the dew point, like for water dew point or hydrocarbon dew point, depending about the application. This is one of the global standard. They need to be in consideration, because as the global standard, as safety critical element, this is one of the key factor which causing the incident, global incident. So the dew point analyzer, very key point to be in consideration. Also the moisture capacitance, also we need to doing in consideration. Moisture capacitance, if we speak, it is like aluminum oxide, and aluminum oxide actually it's working as the capacitor between the gold layer and the aluminum layer, and from there the capacitance we can see how much the exact reading. Also, most of the gases actually need to using the filtration, and this filtration is a different range depending about the application. If we speak about the sand element, uh, or solid element, the proper filtration will be in this range between 40 to 120. And if we're doing proper filtration, it will increase the lifetime for this analyzer. Also, sometimes we doing adjust for the pressure and flow to taking sampling before we analysis. Also, we're using the photometric analyzer. It is very common in this day. Different area they're using this. So it is depend about the amount of light energy of selected wavelength band. So every molecules like oxygen, uh, water, uh, any element H2S, it will have different wavelength. So so we're using the photometric to see how much the wavelength for the specific element. Assume if we speak about the oxygen molecules, it's range about between 760 nanometer. So this type of analyzer only will scan that period, which is between near to the 800 or 760 nanometer, and it will see the concentration of the oxygen in that area. This is a very good technique they're using in different client. Also, it requires different kind of radiation source and detectors. Sometimes they're using the infrared or ultraviolet. For the infrared, actually, it is for light hydrocarbon. They can measure in the infrared bandwidth. Also, for the ultraviolet, it is for heavy, like more heavier component. Also, we need to ensure the filter all particles because the analyzer may respond to them. Also, they may still on the windows. So the more in consideration related to this about this technique, it is not in touch directly with the sampling. So it cannot affect by the sampling in this case. This is one of the technique they're using this day as in oil and gas industries. It is tunable diode laser spectroscopy. So they tune the diode laser at specific wavelength. From that specific wavelength, they can see how much the concentration for that gases or yes for that gases. And actually, the advantage here it is sending the data in the real time. So the data now we can observe it. Also, as mentioned before, it is not contact measurement. If it's not contact, it will require less maintenance, and the lifetime will be high. And also, this will avoid the foiling and corrosion. So if it is not in direct contact, they can avoid the corrosion in the line, and it will increase the lifetime. And also, it provides fast response, as mentioned, as real time. So if we're moving to next slide, so this is the clear picture about this method. Uh, so we're using in different application they're using TDLS. Just so we can see the concentration for different gases like oxygen, CO2, CO, also the H2O, also H2S. We can measure multiple gases in one analyzer. This is very good technique these days, which should be implemented in the oil and gas industries, and it have many features. Like assume if we speak first about this number, it is 2004 nanometer. It is around 2000, which we can calculate the CO2 concentration on that gases. Also, there is other type. It is the wavelength is 1854. It is for the H2O. Here, actually, they're using the very good type of detectors. It is called indium gallium arsenic detectors. It actually can be measured between the wavelength of 800 to around 1800 nanometer. In this range or the range near to this. And actually, this is very good principle they implement to see the concentration for these gases. Also, they're using the mirror. The mirror it will see the reflect for for uh, for these gases, and from this reflection, it will sense by the detectors, and from the detectors, we can see how much the bandwidth, how much the concentration for this gas in that area. If we need to add other element like oxygen analyzer, we supposed to add two other stream. Also, we need to add the laser diode, and from there we can see how much the bandwidth for that element. This is very good technique. Uh, it help a lot maintenance and client team. Uh, but actually, the main problem it is related to uh, this mirror. It is flat mirror. It is gradient index. Uh, but the main problem there is some of the contamination which be accumulate inside the mirror, and from there, if we see there is no reflection for the laser, this means there is the contamination there. And how do we clean it? We're supposed to using like a proper element like methanol to clean it. We cannot clean it anyway because this mirror it is very sensitive. Uh, this is actually all about the, this is just a brief about QMI, which I working on. If you have any question or you need me to repeat anything, just ask me, and I will answer any question if you have.
Thank you, Ahmed. That was really fruitful, explanation. You delve into
Thank you, Hans.
too much details, and you touch base actually majority of the things related to QMI and the process, and also analyzer process, the process of sampling and the importance of sampling. Well, there's one question here. I have a couple of questions actually from the team attended who shared with me. The first question is focusing on the sampling. It says, how critical is the sampling process to the result of the analyzer?
Yes, the sampling process, it's very critical because how much the amount of sampling we need to take it. Uh, because if we speak, for example, about gas chromatograph, the amount of volume we introduce to our analyzer, we're
Mm.
supposed to know. It is between range between zero point 0.1 to 2 centimeter cube. This is how much the volume. So in this range, our analyzer can be working effectively. If it's different than this range, our analyzer will not work properly. So we ensure everything it is done by the sampling system. So the sampling system will send us the amount of sampling which we needed, and we doing proper analysis based on different type of the analyzer.
Okay, clear. So my second question from the team was focusing on the factors. So they said, what is the factor we need to consider when selecting the right analyzer for a specific industry or a specific process?
Yes. So we will have the fluid, and from that fluid we can know how much how from the fluid itself we need to know how much the if we need it required to do analysis or not. If when water application depend, sometimes we're using in the water application, sometimes uh, in oil application, sometimes in the steam, sometimes in the gas. Depend about the process type, we will doing the study and see how much of the how many analyzer we need and where is the correct place to be located this. Some of old industries, like if we're going back like 70 or 90, 60, so when the oil and gas industries it's coming on, so they everything they're doing in the estimation, like they estimate they will need to using the pH in that area based on the reservoir analysis. But this data actually change because the fluid is changing, and they may take maybe 5 years or more during the operation. When the fluid is changing, that analyzer itself cannot be working effectively. So they taking that some time, or sometimes they rising like idea or proposal to implement this type of analyzer.
So Ahmed, just to summarize it, you said you need to know the specification of the product that you are measuring, and also you highlighted maybe in the beginning also the requirement of the customer. If the
Yes,
customer need a specific on a specific accuracy, or
yes,
if there is let's say a supply agreement or a specific legal
or
agreement
yes,
detailing this. Yeah.
yes,
So
all these input, yes, they consider from
mm,
different team. They everyone doing their estimation, and they
mm,
see if it will be applicable or not in that area.
super. Last question is regarding the people who are new in this field of QMI and product measurements. What is your advice to them if people they are just started to learn more about this? Where is their what is the process that they need to do in order to have a strong knowledge in this field? I mean, specialized field.
Yes. So this is very interesting point and question you ask me. It is about the application or for the QMI or the analyzer. If we speak about the oil and gas industries, the analyzer will be located everywhere, in power station, in gas station, steam, everywhere. The analyzer will be located there, and it will have the bright, very good future related to the QMI, and it is very interesting topic. A lot of technologies it's appearing in this area, Also, the team, they need to reading more about, or they need to sharing the new technologies maybe they discovered or based on their assumption. This is very good field to be consideration. Yes, this is a very good question.
Yes. Thank
Yes,
you, Ahmed. I would like
Thank you,
really
Nasser.
to, yeah, I would like to thank Ahmed for his time and support for this. I mean, very good. Very good presentation about QMI. I'm sharing now the QR code for Ahmed's LinkedIn profile. If someone is really interested, he can reach out to Ahmed, clarify your points, have a direct message with him, and hopefully you can Ahmed can guide you, or you can learn from each other regarding this topic. So thank
Yes,
you
yes.
again, Ahmed, for your time and your valuable sharing this valuable insight.
Thank you, Nasser.
Yeah,
Thank you for your time also.
thanks.
If anyone have questions, they can contact me anytime.
Thank you. Thank you.
Yes,
So
thank
I
you, Nasser.
will just thanks. So I will just touch base on one of the topics here with the team that they have highlighted about the ISA Oman and what ISA Oman is really presenting in the next maybe 5 minutes. ISA Oman is the local section in Oman for ISA, International Society of Automation. We've been very active since 2016, and we've been doing really an excellent job regarding for the setting up the community. So people they ask about what they can do in terms of membership. So this membership is for professional and students, and for ISA we're looking into connect with the community, connect with different professionals, grow by providing opportunities to build your resume and job opportunities, and also to learn with the different international standards that you can utilize for work or for learning as well. Uh, we have ISA Connect, one of the portal, our twinning portal, that once you log in and become a member in ISA, then you can have access. But I would like to focus that ISA is not specifically for oil and gas or energy in specific or in some areas. It touch base different divisions for a different horizon or line of businesses. As you can see, we have a 16 division spanning from aerospace, analytics. We have also for food and beverage, mining, water and wastewater treatment, all of these and processes and measurement and control, building smart housing or smart buildings as well. So we really focus on different division that definitely it will have an automation and cybersecurity and control, process control within that section or in that division. We are scattered around different countries, around 33 countries, and we have an overall ISA. They have around 103 section around these 33 countries. What help or what really bring benefit to individuals, either students or professional, is the features like and the benefits that ISA they are providing, such as career center where you can find job opportunities. We have also ISA Business Academy. It's around 10 weeks mini MBA, Master of Business Administrating program offered for mainly leaderships. We also have a mentoring program for both students and also professionals, young professionals, and also having the services to mentor them and to guide them to with a more professional and experienced professionals in their line of business as well. So ISA Oman is very active across different social media. I think now maybe you are watching us in through one of our social platform, LinkedIn, YouTube, X, or Instagram, and we are planning really to expand more into a other platform where we can engage with different community in that aspect. So please join us and benefit from the membership of ISA and what ISA can offer you. This is the end of our Knowledge Connect session for for this time, and we are looking forward to have you in the upcoming session, inshallah. Stay safe, keep learning, and please join ISA. Thank you.